Good afternoon and welcome everyone to session 4 of our mining webinar series, Great Minds Think Alike, where we will be digging deeper into the complexities of mining and exploring business below the surface. The reason we created this series is because the mining landscape has changed dramatically over the past few years. There are multiple challenges and trends, including more complexity, efficiency and productivity losses, environmental challenges, and safety challenges. But there are opportunities too. We can reevaluate our methodologies and employ digitalization and automation, use new technologies to enable better visibility. Initially, we will gather a big picture overview of the current challenges and trends, and thereafter dive deeper into each aspect of the complexities faced by mining companies, along with the approaches and tools to overcome those challenges. With the mining industry incurring billions of productivity and efficiency-driven losses annually, it's imperative to consistently reevaluate the methodologies we use. The mining industry has taken the same approach to mine planning for over 30 years. We need to employ new methodologies if we expect to get different results. Because the value chain is so complex, we have created a separate session for each element in order to really dig deeper. We have muted everyone just to eliminate background noise, but we do want you to interact. So please do put questions in the chat box and we will try to answer them all at the end of the presentations. For better viewing experience, please click the 3 dots at the top of the screen under the button that says More and go to full screen. I'm going to hand over to Ian Huntley, CEO and co-founder of RSPH and the Manufacturing Accelerator Program. Ian is an internationally experienced business leader with over 45 years of experience in large and small corporates, particularly in the mining industry. Ian, over to you.
Thank you. Hopefully the slides come up. Let me just get to share my screen and into presentation mode. So, right, can everybody see the screen?
Yes, thanks.
Okay. So we're talking about great minds think alike, and balancing supply and demand is a critical part. So, but before I go into that, let's talk a little bit of a rifle shot. We have recorded and we are recording all these videos. So if you need a bit more background, Guy and I started Rifle Shot 21 years ago. However, many of our mining and metals customers go back more than 40 years. So the purpose of Rifle Shot, and that's where the name comes from, is to focus on the value chain, the business, why you're in business, and just how can we help make a difference. The opposite is shotgun. And we see many companies that are quite frankly all over the place. We don't think those companies will be profitable. They may not even survive, and I'll come back to that. We look to consistently improve our customers' operational business performance with social conscience. We do it through a number of leadership programs. We've trademarked our innovation, which looks at innovative ways to build the business, grow the business, and provide that thought leadership. We look at the human capital development because the old mantra that we tend to use is people, process, and technology. I know our partners on this call today will talk about the technology, which supports the process, which helps the people do a better job. We think that not only do you do transformation in terms of social conscience, but you need to do it in terms of business. And in today's world, you can't do it without digitalization and leading focused technologies. As Rifle Shot, we've specialized in some core competencies across the value chain, and we'll show those at a later stage. But those are important, and everything we do is around what adds value to the business. Then, of course, we look at the supporting environmental, social governance, and ESG. In today's world, you need all of those. So a little bit more of some background. So we established the company in 2001. In fact, Guy and I were at Futuristics, which merged into IS3 at that time. We're a self-funded private company. We have a number of key strategic clients over many years, but those alliance and our partner ethos is critical. So we believe that we work with the customer first in mind, but not just a customer, our supplying partners. We have the business and IT experience or information management experience, and just in the leadership team, more than 180 years of business industrial experience. I know I ran my first plant more than 50 years ago. We have a strong resultant approach. A resultant being different to consultant in that we strongly focus on delivering the results. What our customers are looking for is results, not a consultant who's going to charge by the hour for the rest of their lives. And I mentioned a bit earlier, the operational improvement, and that's a key part of the focus that our next speakers, Samir and Paul, will touch on. We're a member of the Madala and Associates Group, which is a BE Black Women-owned Level 1 organization. But before I introduce Samir, a lot of time we've spent in particularly the mining industry. If you look over 100 years, commodity prices in general have been decreasing. However, working costs have been increasing, whether it's change of labor, additional regulations, environmental, different overheads. If those two lines meet, you go out of business. Now, Samir and IS3 are some of our partners for quite a long time in terms of helping flatten the curve, because the only thing you can really do is increase your volumes and decrease your cost curves. Samir, Head of Sales Enablement from IS3, is our partner in this regard. And what I'd like to do is hand over to Samir to talk about what he has to offer. Samir, over to you.
Thank you so much, Ian. I'll just share my slides. Right, hopefully I'm coming across clearly.
You are indeed.
Great. Thank you so much, Ian. And good afternoon to the audience. It is indeed a privilege to be part of this session. And thank you so much to Rifle Shot for including AVEVA and ISCube in the series. Great minds think alike. Very, very inspiring. Today, yes, as I said, it's going to be my privilege to introduce you to AVEVA's solution, Production Management, which was formerly known as Ampla, and I'll be joined later on by Paul, who's going to give us a quick run or drive-through of the solution. And just picking up from what Ian has just mentioned, this new digital era that we're in, for all industrial organizations, it's here. And for mining organizations, it's no different. Today's volatile commodity prices, the evolving environmental regulations, and declining investment means that miners need to shift their focus towards more operational efficiency and stay ahead of that curve. Safety, social license to operate, and sustainable practices remain at the forefront of all operations. And employee safety and well-being must come first, as well as that of the local communities and their stakeholders. In fact, the well-being of the very earth that we dig into also needs to be considered. So, with all of these challenges and business priorities, how can mines be sustainable, keep its workers safe, and maintain respect and care for all stakeholders? And the answer lies in digital transformation. Applying digital tools and principles that enable mining companies to make the most of their efforts to process the information and make the best business decisions possible for everyone. Many organizations are attempting to analyze and manage and unify their data processes as well as their supply chains. The challenge that many mining, minerals, and metals companies now face is understanding how to bring these principles together in a systematic, comprehensive, and intelligent way that will truly transform their operations. As with all other industries, it's essential to operate with the highest levels of efficiency, corporate social responsibility, as well as regulatory compliance. And when applied successfully, a digital transformation strategy can accelerate your mining operations, enhance your productivity, reduce your costs, and help you surpass your competition. Today, I will be sharing a few of our customer references and successes that they have had with the AVEVA technology. Digital transformation is helping mining companies globally save more than hundreds and thousands of dollars in unplanned downtime, increase their workforce efficiency, and improve their data accuracy. But what does it take to implement this digital strategy successfully? And where do you focus your efforts as a mining organization to get the greatest returns? Here I have a few areas that mining companies would try to focus their efforts. But first, the first thing that you need to consider is enhancing your edge to enterprise visibility and control. Okay, ensuring that you have complete visibility of all your assets across your supply chain. Then you can look at optimizing your value chain and understanding the health of those assets and the productivity. On screen, you have a few categories: process productivity, energy in terms of water, pressure, power, asset reliability, environmental health and safety, quality assurance, KPIs, and reporting. And there's a few technologies that can be leveraged in order to achieve desired results. For example, in terms of asset reliability, applying predictive analytics. In terms of production productivity, you could apply advanced process control. These are very common technologies within the industry, but helping you understand exactly where to apply your efforts. The core there is understanding the information that needs to be unearthed from the value chain itself. So just to simplify this, I'm going to look at 3 categories of information: energy management, asset utilization, and material tracking. And in the next few slides, unpack exactly how complex this could be for mining organizations. So here's something that should be familiar to you: the mining value chain. Looking at it from the pit all across to the port. Of course, this is a very simplified view. You do get mines that are quite complex with multiple streams, but the nature of the industry is that it is continuous. Many assets. And yes, you would assume that the material would flow from upstream, downstream. But here's where things get a little interesting. The information actually needs to flow in both ways, both upstream and downstream. And on screen, I have a few indicators of what sort of information needs to be captured in terms of asset utilization. And how is it that mining organizations capture this information nowadays, or as of recent decades? Well, they might rely on manual data capturing systems, perhaps maybe Excel spreadsheets. And some of these are prone to human error and delays in terms of feeding that information forward. And why I mentioned that information needs to flow in both directions, well, if you just look at spot asset information, it's not just conducive for decision making. I'm going to explain this in a quick example. Let's take a look at this conveyor. It's transporting material from the plant to the stockpile. Now, if this conveyor had to be down for whatever reason, maybe due to maintenance, or it could have been due to a breakdown, um, fine, we can classify that as the reason for the conveyor being down. But actually, the impacts of that conveyor could stem both upstream and downstream. If that conveyor is down, it prevents the plant from actually producing. There's no place to export the material to. Okay, so actually, in terms of your asset utilization system, what you're looking for is a system that can classify not only the cause, but the effect it has on your value chain, okay, as well as the location for where that cause has occurred. So that's a typical example of an upstream uh, issue. The reverse is also true. What if the stockpiles hit their maximum capacity? It prevents um, it prevents the conveyors from running further, and it prevents the plant from producing. Now you're left with a whole lot of idle assets which are perfectly operational but can't operate because of issues further down in your value stream. Right. So what's needed here is a solution that can properly understand asset utilization, not just in the context of the asset as an island itself, but across the value chain. The next information example would be around material tracking. So again, you can see some of the data items that need to be captured, like what was the actual tonnage that was mined? And then where is the material going to? Which stockpile is it going to? In fact, where is it coming from? Is it coming from the right put body or block? What grade was it mined at or scheduled to be mined at? Can you classify all of these material movements as we go across the value chain? This is very, very important for the system that you need to capture all of this information. Yes, information can be captured manually, but as I've mentioned before, this leads to delays in the process. Knowing exactly or actually how much was mined, was that according to the plan? And if it wasn't, what's the plan to correct the mining procedure? Okay, can we meet the weekend's targets, for example? So getting that information flowing freely through the system as quick as possible will help with your planning and scheduling needs. And we've been talking about sustainability. So of course, understanding energy usage across the value chain becomes imperative. Not only just to achieve sustainability goals, but to ensure that the commodity that you're mining, their prices are profitable, and that you do have an understanding of what the costs are to mine this commodity, okay? Especially considering the energy usage involved. A system needs to accurately capture this energy usage throughout this continuous process, being able to classify all the events for when a piece of equipment has started, the amount of energy it was utilized, and the amount of product that was produced as a result of investing in that energy. From there, we can take this information even further to better understand what is the desirable or the most objective way of using our energy to achieve the right productivity goals. Hence, gearing towards sustainability. As a mining business, here's a goal that we should all be agreeing towards, and that is to have a dynamic and responsive value chain. What does this mean? We can maximize the reliability and availability of our assets, extract that information from those assets and make actionable decisions and provide insights into how we are running that value chain. That information can be then shared across the workforce to ensure collaboration and better information usage. And thus being able to more effectively close the loop between incidences, issues, and production inefficiencies so that action can be drive better productivity. But just to reiterate again, the current state, the challenges that our organizations face. Gone are the days where a mining expert would reside on the mine for 30 years, okay, and gain all of that institutional and mining knowledge, and share that with his workforce and his colleagues. Now we're seeing that shift where the workforce has evolved. Younger generationals are coming in. They don't have all of that institutional knowledge. Okay, they're expecting it. They're expecting it to be delivered to them by digital means, and being able to leverage and question those digital systems for what their answer could be and solve their challenges. Another common challenge, disparate data without context. If mining organizations did mature to leverage systems, most of those systems still operate within silos. What's needed is to break down those silos so that your actual tonnage, for example, your production figures, marry with your planning and scheduling system so that you can create that holistic report and then further understand from your maintenance systems that these assets are due for maintenance and then plan even better and accordingly. Okay. As with all industries, there are going to be cost constraints. However, we should be able to understand what those cost constraints are so that we can make the better business decisions to mitigate them. Also very common within this industry, conflicting KPIs. Should we run that conveyor even though it is due for maintenance? Why? Because we're not going to meet our weekend targets if we don't. So you have now your reliability engineers conflicting with your production supervisors. What's the best decision to make? Do we have enough information to make that decision? And of course, if the information is not flown freely, the entire organization is slow to react. Can you imagine getting your production figures a whole day late? Well, that's not up to imagination. It's happening. So your entire decision-making process ends up being deferred. So hopefully that you do share these sentiments of these common challenges. And AVEVA have understood this industry for many, many years now. In fact, they've put together an entire portfolio focusing on challenges within the mining industry. Today, we're going to unpack just one of those solutions, and it is core to enabling many of the other solutions that I've mentioned. And that is going to be AVEVA's production management system. And I'm going to unpack it in 3 methods, and by introducing you to some of the great minds that were able to achieve great results using our solution. Firstly, focusing on increasing performance and processes of assets across the value stream. As I mentioned, the system needs to be able to pull data from existing systems, manual data sources, as well as your workers in the field. Bring all of that data together and create the context needed to understand that information. By context, we actually mean a model depicting your entire value stream. In terms of assets, you might be familiar with the S95 structure, but being able to understand every single asset across the value chain. The system needs to be able to model those assets in an effective and engineering efficient way so that data and information can be presented in context. Here is an example of a customer that was able to leverage this facility, MMG. So one of the core business drivers for MMG was to generate value through this digital transformation. And their strategic intent was to drive business efficiencies, hence leading them to being a great mine. And it led MMG to implement what they called an asset utilization program. Now, the true power of this asset utilization program was to deliver real-time OEE. That's your overall equipment efficiency or effectiveness. So firstly, what this did was it provided operators and production personnel with real-time targets that were based on sustainable and achievable tempos or rates, given the current feed grade and the equipment availability. So now operators were able to tweak the process to achieve their production targets, rather than the old traditional reactive approach to OEE management. So what this meant was the system behaves more like a control system than just a reporting system, allowing for immediate intervention to help ensure losses are mitigated and minimized. And then secondly, it was now possible to better understand the constraints um, that cause those losses, so that strategies could be initiated for improvements and so forth. And then those constraints could be controlled over time. So all of this information becomes invaluable for personnel, metallurgists, process engineers, reliability engineers, to diagnose, the root causes and the constraints, and then help recognize those reasons why the process ran either below or even above expectations, and learn from that. So this is a great example of MMG. They were able to deploy this solution, which was based on AVEVA's production management system, and they were able to deploy it across 3 different continents. And that just suggests the standardization nature of the solution, AVEVA Production Management. The second aspect of the solution is to improve the agility of the value chain. Now, here, I've spoken about being able to model the assets. Now, you need to be able to model your material movements, model the inventory across the entire value chain, so that you can monitor and react to changes in your stock volumes, your qualities, both as estimated as well as measured. So you'll be able to measure and estimate your stockpiles, okay, and have a full history as to how that stockpile was filled. What mining blasting block did it come from? What qualities were used? Now, this is valuable, and this valuable and accurate information can be shared with all other systems, like you've got on the screen right now, your higher order systems, your material reconciliation systems, your planning and scheduling systems, as well as feed forward to your ERP systems and support your master data. So here's an interesting example of another great mine that was able to leverage this facility. This is a story of an iron ore producer in Western Australia. That's Roy Hill Mining. And they were able to visualize and control their mining value chain from 1,300 kilometers away via their remote operation center. So they were able to optimize their entire value chain for the year ahead and break it down into quarterly, weekly, and daily activities from that remote operation center. And what ended up happening was that 80% of the execution was being done remotely, and this was due to their investment in the AVEVA technology, and namely that was AVEVA Production Management as well as AVEVA Unified Supply Chain. So there's quite a number of exceptional quantitative numbers that can be shared regarding Roy Hill, but I'm going to focus on one of the biggest gains. And it was that they were able to achieve their target throughput 6 months ahead of the planned target. Okay, so can you imagine what this would mean? And they were able to do this remotely. So imagine if this was for a greenfields plant. Being able to achieve your target 6 months ahead of time, that's 6 months pure margin directly to your bottom line. Third aspect of the solution, being able to reduce your capital and operating costs. So monitoring equipment hours and those start cycles has to be part of the solution, as well as understanding the scheduled maintenance. So your solution needs to understand the running hours, your equipment hours, and how those hours or that time is being used, and classify that information correctly. So here's another great mine, Talison Lithium. They came to AVEVA looking for ways to track and measure operational processes. And that included understanding what triggers and drivers were causing these processing plant stoppages. AVEVA Production Management was able to provide an appropriate time usage model. And this provided governance and a hierarchy to identify and categorize these events so that they can gain an understanding into their losses that were being portrayed. And then further analyze that. So metallurgists were able to create a continuous improvement strategy that maximized their plant uptime, as well as their process recovery, and extend that to their product yields. Now, these were just 3 great minds that I've mentioned. The solutions that AVEVA bring to market are helping leading companies achieve all the results that you see on the screen. The 10% increased production, improved overall equipment efficiency by up to 15%. They've reduced cost in maintenance, and the overall 80% reduction in safety incidents because of the sharing of information. AVEVA is helping these leading companies drive efficiencies throughout their mining lifecycle. And it allows them to embark on their digital transformation journeys. So just to highlight some of the key features that AVEVA Production Management brings in to your mining organization, you're able to now understand your delay accounting, capture downtime, these delay events, and understand the effect that it has on the rest of the value chain. Of course, understand your production. Compare actual production to what has been scheduled, what has been planned. Okay. Understand your inventory and your quality management as the product or commodity is gaining value through the value chain. Perform material balancing and accounting. This makes your reconciliation a lot easier, understanding where material movements are coming onto your stockpiles, your product stockpiles, and leaving your stockpiles. Sustainability management, being able to understand your energy usage and your reporting and your consumption over time. Being able to create shift logs so that your personnel can now better collaborate with one another. The solution is also mobile. So and this will be demonstrated to you in a moment, you'll be able to gain access to all of this information via a mobile interface. And as I've mentioned, be able to integrate with other systems, your planning systems, your material reconciliation system, as well as your ERP systems, so that information can be brought right from higher up down to mining shop floor. So I'm sure many of you in the audience are now waiting to see what the solution actually looks like. That's where I have now my good colleague, Paul Kotzer, that's going to take you through a quick drive-through of what AVEVA Production Management entails and how easy it is to actually configure. So with that, allow me to hand over to Paul. Good afternoon, Paul.
Hi, good afternoon, everyone online, and welcome to our session here. And thanks, Samir, for the intro. Let me just get this out the way here. Right, so first of all, what we're going to do is we just need to recap on some of the fundamentals, and then we're going to go into what it actually looks like and how you configure it. So if we start at the bottom line, we're starting with the data store, and this is pretty much where we share our information from. Right, so this is where the system typically sits at and runs at. Then the next thing the system actually is built around is the data collectors, which is a critical part to capture all the information that we need. And this includes your real-time data connectors like OPC, traditional IO drivers, and so on. And then we've got historical data that we can access via OPC HA, and we can access normally with the AVEVA Historian. So what the feature that allows us with that is the backfill capability that it allows us with. And then general integration with regards to files and so on. So it pretty much opens up the communication layer in order to get all that automated information in. The next section that we want to look at is the MES modules. And as Samir has pointed out, we're looking at a couple of ones. The first one I want to point out is the downtime module. And that basically is capturing downtime, self-explanatory. The next model that we look at is inventory, and that is in order to allow the tracking of blocks and movements and seams and pit material in through the entire value chain. So that gives you a good balance of what is where and where did it come from, basically material tracking. On the maintenance side, allows us interfacing to your PM modules or what predictive maintenance system that you use, Maximo, SAP PM. And what that allows us to do is to feed run hours of motors and so on, or equipment directly into that systems. So you're changing your maintenance methodology from calendar-based to actual usage-based, so that you don't spend unnecessary maintenance on equipment that's not really running. Next one, production module, and that is capturing associated production-related information with your schedules and your sequences. So you're starting to contextualize information together with the production module. Over the metric side, fancy word for your traditional KPIs. And this is where you actually can set up your KPIs that you want to use and need in your organization with your own classifications and formulas and so on. Knowledge points we use to formalize shift handover procedures and capture general information. So instead of a piece of paper in a control room or something verbally communicating something, the person can capture that information directly into the unit, and it's allowable and traceable. Energy management, we use this to identify overconsumption. It works in theory around about the same as a downtime module, where we look at data streams and then determine if something is consuming. And then we try to identify the reason why there was overconsumption happening. Schedule and planning, this allows us to look at your train load schedule. The example I'm going to show is loadout schedule. So it compares your running, it's like an MES work order running against a schedule that you have to load and complete and so on. So this, I'll show you this in the demo. And then last two is we've got quality information associating geolocation and quality data with your blocks, and then feeding it through your plant. Gives you better control on what to expect, the blocks that's coming in and the quality that's online. And then the last module is cost, and then we look at cost of breakdowns and stoppages and so on. So that typically is the MES modules, and these run on top of these data collectors, as I've explained earlier. MES solutions, further expanding on, I'm not going to get into it's a separate target audience, but that's more about metal accounting and energy optimization solutions sitting on that. The ones that I want to do focus on is what I've highlighted, and looking at application services. This is just what we're running, communication infrastructure and then public interfacing and so on. Integration side, master data synchronization and so on. So that's my pretty much stock standard. And then the tools that's built in on the top is the configuration studio, which I will be showing you the following demo. Production analyst is what the user sees. So configuration studio is what the engineers use. Production analyst is what the user sees, and then supports dashboarding, SQL Server reporting services, master data, and then API interface, which is SOAP and REST based. Obviously, this forms part of the whole value chain optimization. And you can see the supply chain operations session. There's a session tomorrow on this, so that will give you more detail on how this interfaces and connects to each other, and then other systems, normally your LIMS and quality system and so on. So diving into the actual configuration studio, this is basically what the system looks like. And I'm not going to deep dive into everything because we're limited on time, but I just want to highlight a couple of key issues. One is the material model, which I'm showing on the screen. And this is where we basically build your material model up. Next one is material movements. So here we model the actual movements of your mine. And on the right-hand side, I've got an input to crusher movement. And here we can see you set up your sources, definitions, your lot behaviors, first in, first out, in your destination, how it must group the items together, and the materials that gets moved in that utilization. So on the maintenance side, we have database sources. And here I've got some interfacing that I'm running to get my work order table. and OLAP-DB connection, straight SQL connection. So that gives you an idea of how we get those out with the work orders, but I'll show a bit later. And then as your data streams are coming in, you can actually see the values changing in the samples that you're receiving. So you can actually see here is just a load cell resetting and setting the whole time of my tank level. Right, closing that off. And then we're going to move over to another important function is data imports, because there's a lot of external data that we're bringing in to bring it together. And this typically comes from your geo samples or your geo database. So bringing that information in as well. Then equipment modules. So we classify equipment types, conveyors, bins, chute, crushers, and so on. And then we build a relationship matrix. So reason codes and then the classification of those. And we stitch them together with that matrix. Course codes, as we've just seen, there's some generic breakdowns and some reasons that we use, and this is what we'll give the operator. On the classification side, time usage model as your company gets defined for. Period's important one because we want to roll up data. We don't want to look at the streams. So we look at 15 minutes, hourly, daily, weekly, and so on. And then some timers in there to trigger stuff at certain periods of time. That is basically the data sources. Adding one, we just right click, we go connectors, and there's a whole host of connectors that you can see that as default off the shelf that we can connect to. And then on the database integration side, there's the options with regards to that. So this is typically how we get data into the system. Okay, building the model. So the system is built around the S95 standard naming convention and so on, the modeling. And here we've got, I've got 3 coal plants, basically an iron ore plant as well. And then basically what the model looks like, I've got a pit, there's a stockpile which is called ore in. And then on the right hand side, we configure the behavior of that physical stockpile, and you select how material flows in and out of it. And then what material is associated with that stockpile. And here I've got mining iron associated to it. On the quality side, what do we want to measure? And there's 4 quality variables that we want to look at, and these typically get imported in your geo model. Looking at the ROM side, we're expanding the modules. So now we've added the downtime module with slow running virtual downtime, and then when something goes wrong and the crusher is basically stopped, and then the data fields that you want to record when that event happens. On the crusher side, decision matrix, this is where you can create first up alarms and so on. On the metrics, as I've explained, your KPIs, and this classification is what you define it as, and the naming convention that you use and the rules that you use. Some might use performance numbers, some might use utilization, some it all depends on what you want to do. I've also got factory efficiencies and so on. So that's your classification. Energy side, pretty much hand in hand with the downtime module. And there we've got stuff that we want to capture when we have an overconsumption event taking place that we've picked up. Production side is where we actually capture that production records with the data. Maintenance, what are we looking at? Operator log. Operator log is formalizing that shift data and handover. I will show that in the demo as well, just in a while. And then on the maintenance side is feeding that run hours into your predictive maintenance systems. Okay, so that is basically that. And then we're adding a couple of feeder knowledge points and some drawings in, so somebody can just click on a piece of equipment, it can show a drawing for him or any information that he wants to associate with that piece of equipment. The last one is the planning module. And here is just train number and train order number. So that's typically coming for ARP. So now we've got a basic understanding of the modules. How do we build it? And this is where the benefit and the speed comes up, is that you just select your area. I'm going to create a new area here. I'm going to do it ROM. And then what we want to do is we want to add some reporting points on there because we want to start reporting information. I'm just going to classify a storage unit as well, crush and stack line. And then we're going to be adding the modules that we want to record against it. So going over that, we're going to reporting point, and we're going to add downtime. And then if you want to do some production records with it, you add the production reporting point. And then you configure those. And that is the benefit in the speed in which you can roll out your solution instead of custom coding or some other software that you use. So that's the main speed of it. Okay. So now that we've seen the configuration studio in a nutshell, let's look at production analyst. And this is where our actual users will log in. And this runs on your Active Directory groups and security and so on. So security shouldn't be a problem. Okay, it's browser based as well. So you can see the bottom side is the modules, and then the top side is your hierarchy of your plants and so on. And your tree will change based upon the module that's selected, and the module will activate the tree based upon the model that you've built in the hierarchy, like downtime, production, and so on. Looking at some charting options here. So we don't fix the reporting. It's not fixed report, so you can play around and find your own report types that you want. Here I'm just showing some analysis by and groupings by and so on. And this is dynamic. So when you change it, it's there. You can save it as a template if you want to as well, and it will reload your data. And you can share it with others, like a daily report or a morning report and so on. And here we're just playing around with some filtering just to get a bit more data in and show you the charts and the tank level in the day and the night shift. So this is typically all the tools that you would need, and it will assist you with analyzing your data and understanding it. If you want the detailed data, there's data grid available at the bottom. You just switch and click and change your chart. If you want to take it away and just have it in a table format, you can do that. Copy and paste the data in Excel if you don't want to retrieve it via API calls or SQL, CLR procedures. So here we're just switching it back on just to look at the rates charts and so on. Okay, going over to the downtime, which is the crux of the matter usually, is what we're doing is we identify those stoppages and then we're generating those events. And then we can see the red ones is where the operators hasn't supplied us the root cause of the problem yet. And the reason why we look at root cause is it's much better than a first up alarm after the investigation's been done. So here the operator would typically select his conveyor, would like the source code of what the stoppage was. And because we set up that metrics in the beginning, we already know it's an unplanned operational downtime. And now that information is being captured. We can also further the totals in the back at the bottom. You can have some averages and accusations, averages, and whatever you want to choose, how you want to summarize your information. Looking at the downtime again on the plant section, here we look at a burrito chart, and this gives us an indication of how many events we've had, what the stoppages was. And then I'm also going to change the classification here just to give you an indication of what that is. The Gantt chart, everybody's favorite. Doesn't look like much at the moment, but when we do split it up, when we change a couple of filters, we can actually see where the issues was in your over time. Pie chart, not functional, but everybody wants them. So just need to show how we look at. Full audit trail history as well, so we can see in the system who changed what value, what the new value was, and so on. And this is applicable to all the modules. Over to the energy side, we want to look at overconsumption. And as I've indicated earlier, it basically works the same as the downtime. We identify an event, we give it classifications, we give it reason codes, and then we can analyze that information in order to see if there's any common occurrence or where we can improve, and so on. For this example here, I've got soft and hard ore that we're looking at in the top, and it will just basically identify what ore is normally associated with that overconsumption if you want to copy it like that, associated. Here we just say feed type materials classification, and we save and close, and that event is associated. So if you refresh the Gantt chart, we can now see it's got that cause in the feed type. There's a reason for it in the Gantt chart. Okay, moving over to inventory, as I said, this is the tracking of the material. And here I've got multiple areas. And what you can see, if I look at the ROM and my ore, I've got balance by lot, and here is the blocks data that's available in the system, and this normally gets imported from your geomodel and your mine plan, and so you can actually track. So we group it together by pit. They've pit 1 and pit 2, then movement events. It will show us the movements that we've had in and out, and so on. So these are multiple filters that you can use, and there's multiple fields. Let's bed them together. So now you can actually compare your input flows versus your output flows of your ore as you're mining, blasting, and so on. On the product side, we can see what we're feeding to the stockpile and what we're taking out of the stockpile. So this basically tracks all your material, and there's a whole host of filters and options here that's available for you to use. Okay, going back to balance by lot, we can see that the quantity is here 40,000 on the stockpile, and let's say you do a survey maybe twice a month, and they realize that the tonnages are out. we have the option to manually correct that, and it will reprocess all the transactions that took place after that point in time. So here it's the 5th in my sample data. We're going to change it to earlier, and then we're going to save it. Oh, select the equipment type. We haven't told it what it must balance. So here you're going to select the stockpile. We're going to select the product stockpile, and we're going to say what group is lot group product, which is a grouping, and the new balance needs to be 2000. We save it. And now what we'll do is with the reprocessing is we'll reprocess all the transactions after that date that's changed in order to rebalance all the downstream movements that you've had already. So if I refresh this now, we'll see that our tonnages are now corrected to 2000 as a survey adjustment. So full balance and checks that you can have with regards to the inventory side of it. Okay, going over to the plant, the last thing I just want to show is inbound material flow. So we can measure those independently as well. If you just want to look at inbound, the same concept applies for outbound material flows and so on. So normally we use the balance by lots is the important one because it tells you the averages for your stockpile and how much stock you've got in a pit specifically. Going over to the knowledge point, we're looking at the operator log. Now we're formalizing our shift handover or notes that we want to capture. And in this scenario, what I'm doing is I am adding shift notes. So we had no issues on the area 1, area 150, no issues as well, and area 200 not applicable. Operator, by default, you can select what you want to associate by default or not. And on the safety side, we're going to say we have no issues that we've identified. Pass score for the shift is maybe an A. So this typically gets set up according to what your needs are and client, but it gives you the full ability to formalize a lot of things and to keep it in the system with full traceability and tracking. So now we add it. So if you want to capture manual data into the system, you can do that by creating these knowledge reporting points and so on. Just going to show you here some older data that I have. And there we have some other issues where the area wasn't clean and there was no issues identified and so on. If there's a quick question with regards to a drawing or some layouts, you can do that by the association of it, like I've just shown. And then the secondary thing is we can carry on individual equipment. So there I have a feeder drawing. And then on the crusher side, I'll just give you a motor drawing that we've got. So if somebody walks up to the control room, we can quickly ask an operator to check something for them on a piece of equipment if need be. Going over to the maintenance side, I've explained this is where we can interface and create work orders to your plant system. And here I've just got an examples of a couple of equipment. There's no orders of those. And on pump 2, I'm going to submit the work order request. And then we're going to give it the fault code. If you can pick that up via automated signal, it's great. And you can generate it like that. Or we're just going to ask the operator to provide the details to us. In this scenario, we have a gland leaking on a pump. Okay, priority, we assign those by default, and this we built into that configuration studio that I showed earlier. The job number and that stuff will all be submitted and generated automatically when the information comes back from your request that you've sent off. So that's typically what we do with regards to the maintenance side of it. In the orders here, I'm just giving some orders complete. So it gives somebody an option to see what orders are outstanding on the equipment and what has been scheduled. Further on, we look at the run hours, as I've said earlier, and these are typically posted off to your maintenance modules, maintenance system, so that you can see what you're actually running at. Going over to the metric side, this is where our OEE sits, and I've just used the generic classifications for OEE and availability and so on. As I said, this is normally business dependent, and the classifications and the rules that makes up that numbers is normally done by the customer themselves. So these are just the generic ones that I'm showing here, and averages and so on. This is where the periods come in that I alluded to in the config manager earlier. And here we can do per hour, per 15 minutes, per day, per shift, month, yearly. And what it will do is it will roll up your totals for you per year into that time period that we're looking at. So it gives you great flexibility in order to do it. On the planning side, this is typically what we'll do is we'll import the schedules like you have your outloading, and this can apply to any typical typical function that you want to perform where you want to track against orders and so on. This is more MES terms. And here we've got the order, the train number and the order number from the ERP system, and it shows us on the calendar how we're loading the trains. Looking at the analysis of that loading, we can actually see what material we're looking at. And I just want to change one here, and then we can see what we're looking at. I'm just want to change my filter in order to get more data. And we can see how it now suddenly changed when you look at the analysis of the data. And here we can see close departing and so on. So this gives you a Gantt chart of how you are loading your trains. On the top bracket, we're seeing existing ones that's busy loading, scheduled once it's departed and so on. So it gives the user, as I said, good flexibility to play around with and get the views that they want without any hard coding or reconfiguration on the reporting side, or somebody that has to go and rebuild report. And here we can see just all the trains that we've loaded up in our system at a glance. Last module, quality, and this is a very important one, and it normally runs hand in hand with your inventory modules and your blocks. And what I'm going to show you here is an example where we've imported the geoblock data as from the geosampling. And then what would happen is on primary crushing, if you don't have a update on that, that quality will carry forward. And here you can see it carries through throughout my organization. Going back to the ore, we've got some basic SPC charting and capability. And here we're doing some thresholding. We're looking at the bell curve, distribution, and so on. And if you have a quality update in your process after the geo blocks, let's say you have an analyzer in the plant, the feed plant, you can actually update that quality, and then all your quality after that block will update again. So it's got full quality moving forward capability, so it will carry the quality that it has until it gets an update again on a specific sample that you have, or quality bucket that you're using. Okay, so in essence, that is the overview of the live system, and we've discussed the fundamentals over here. And then I just want to leave you with some motivation out there. I know we've spoken a lot and we've covered some technical stuff, so I'm going to leave you with the following.
Where does potential live? Does it exist in hopes and dreams? Will you find it in fixed mindsets or outdated workflows? No. Potential lives in people. AVEVA is the catalyst that turns human potential into the power to move mountains by bringing people and technology together. Now you can break down silos and drive value chain optimization to deliver sustainability and growth. And organizations all over the world can leave traditional benchmarks and KPIs in the dust. Mining operations can connect and visualize the entire value chain, improving planning, management, and performance, increasing throughput and reducing downtime and energy usage from pit to port. Close gaps, fine-tune operations, and turn your people into pioneers with a clear path to innovation. It's bigger, bolder thinking that improves how you work and protects the world you're working for. AVEVA knows that potential lives in people, and your people are ready to move mountains. AVEVA, we'll take you there.
Okay, I thank you for your time. Back over to you, Caroline.
Thank you very much to Sam for showing us how much money idle assets really cost us, and that delayed indicators are not enough to be agile. And thanks, Paul, for that insight. The level of detail and complexity in production is immense, and trying to capture that information manually in order to be used meaningfully without a system like AVEVA Production Management seems almost impossible. So we know what we need to do to unlock that human potential to take your mind from good to great. Just one question. How long would it take to move from using spreadsheets to using AVEVA's production management system? Sam?
Thanks, Caroline. That is an interesting question. Okay, so as part of IceCube and AVEVA, we've embarked on a number of projects for digitalization. Now, it also boils down to the size of the industry or the size of the mine. What we found was that, if I had to put it very simply, a single stream mine, right? If done correctly and through our digital transformation practices, you could actually get them digitized in up to 6 months. Okay, but it is a continuous process. Okay, so for a very simple mine, moving them away from Excel spreadsheets to a digitized system can take a minimum of 6 months. And the reasons behind that is there's a number of steps that need to be followed. First, we need to actually understand what we call a data dictionary. What data is actually available, okay, and what is not available. So that's a little bit of a consultation exercise that happens. And based on that information, we can then marry that to what the outcomes are of that organization. Okay, so minimum 6 months, that's what I'm going to say, but it also comes down to the complexity of the mine. If it's a multi-stream complex mine, it can take longer. I hope that provides a little bit of a benchmark.
Absolutely. Thank you very much. And I'm afraid we are out of time. So I'd just like to take this time to thank Ian, Samir, and Paul for your contributions, and to our audience for making the time to attend. We will stay in touch. Thank you very much, and goodbye.